Let's do the second set of factoring examples here. Again, this is going to be another set where we don't know what type of factoring we're going to have to use until we encounter the problem. So we have this trinomial. Looks like there's going to be a greatest common factor. All of these things can be divided by 4. So let's start there. 4 and any letters, yeah, a y. So we can factor off a 4y from every term. And that's going to leave us with 10x squared plus 11x minus 6, and that's good. So that's a messy trinomial left inside. We can deal with those. So I do that by doing a times c is negative 60. And now I look for two numbers that multiply to negative 60, add to 11, positive 11. So let's try 5 times 12 is 60, but that doesn't work. How about 15 and 4? I think that could work. So if I do plus 15 and negative 4, I would get multiply to negative 60 and add to 11. So perfect. I'll use that. So that's going to be 4y times 10x squared. Now what I'm doing here is I'm using these two numbers to split apart plus 11 into plus 15x and minus 4x minus 6. And then I factor by grouping because I have 4 terms in the brackets there. So I'm going to factor by grouping. So that's 4y times, first group I'm going to pull out 5x, leaving me with 2x plus 3. And in the second group, I'm going to pull out a minus 2, which leaves me with 2x plus 3. So all of that can be factored to give me 2x plus 3 times 5x minus 2. Next example, this doesn't look like a difference of squares, but it has 2 terms, so there's a chance. Let's see what I can factor out. 3x and a y can all be factored out. So if I do that, I'm going to be left with x to the power of 4 minus 48 divided by 3 is 16. So perfect, that's a difference of squares. If you don't recognize it right away, x to the power of 4 is x squared squared. So my a would be equal to x squared in this difference of squares. So I'll go ahead and factor this as a difference of squares with a as x squared and b as 4. So it'd be x squared plus 4 times x squared minus 4. And at this point, in many examples, we'd be done. But if you look carefully here at this, this binomial, this is also a difference of squares. So we're not done just yet. We have to factor this completely. So I have 3xy. X squared plus 4 cannot be factored because of this plus. It is not a difference of squares, so I can't factor it. But I can factor the second bracket, x squared minus 4 as a difference of squares can be factored into x plus 2 times x minus 2. So I'm looking at this problem, and it looks like a 4-term polynomial, so my only real strategy for 4-term polynomials is to do factoring by grouping. So before I get to that, though, it looks like we have some numbers in common, 4, 8, 4, 8. We can factor a 4 from every one of those. So I'm going to start by taking out that GCF. So factoring a 4 off that first term leaves me with x squared. The next term, 2bx. Minus 4ax divided by 4 would leave me with negative ax. And finally, 4 off that last term. And now I have my 4-term polynomial with the greatest common factor out. And so if I'm going to try factoring by grouping, I have to do this in pairs. So 4 times this first pair I can factor out in x, and that leaves me with x plus 2b. And in the second pair I'm going to pull out a negative a And when I divide each of those terms by negative a, it leaves me in the brackets with x plus 2b. And that's good because now that we have these common binomials on each term in the brackets there, I can factor x plus 2b off each term, leaving me with x minus a in the other factor. And I'm done.